Hey, so far we are done with many different types of equations, reducing them to the quadratic form and finding their roots. Well, in this lesson, we look at another type. In fact, the last type to be added to your already impressive skill set. Here, you will see 4 factors being multiplied and they are equal to a constant term. What's special about them is, out of the 4 constants inside the brackets, the sum of 2 will be equal to the sum of the other 2. Okay, see this example. That should clear it up. The factors are on the left side of the equation and this constant is on the right. Now, upon careful observation, one can figure out that -1 and +8 gives the same number as that of the sum of these other two. Therefore, we swap these two so that we have the right pair with each other. We'll also shift this constant 19 to the left side. Now, what to do with these arranged pairs? Multiply. After all is said and done, you'll get this. Name it equation 1. Now, look at this closely. Do you see what I see? Exactly. X squared plus 7x is same in both the brackets. This isn't a coincidence. This happens because you figured out the correct arrangement for the multiplication of pairs. For example, in this equation, you can try any other combination and you will get many results but not the common terms as we have in this case. And now that you have them, consider it equal to y and replace it in equation 1. Next, we multiply these two brackets. Simplify it and you get a quadratic equation. Whoa, what a transformation from that spread out equation to such a clean and compact one. You know the drill. It's time to factorize. Multiply the coefficient of y squared and the constant. We get -99. Now, +11 and -9 are such factors that add up to give +2 again and -99 upon multiplication. Next, let's take the common from the first two terms and the last two terms. You get y into y plus 11 and 9 into y plus 11 again. So, y plus 11 can also be taken as common and we have two factors as a result. It's time to equate each to 0. And at this point, in both equations, we substitute the value of y by what we had equated it to earlier. And suddenly, we have two more quadratic equations. Oh God, two more? But take a deep breath. The quadratic formula will get you through this very quickly. Just compare both equations with the standard quadratic form and find the ABCs. Once you get them, put the values in the quadratic formula. 7, 7, 1, 1 and 11.7, 7, 1, 1 and -9. Now, all we need to do is to simplify. Apply the squares and multiply the numbers. And we are just about to be done. Just solve the radical. 49 minus 44 is 5 and 49 plus 36 is 85. There, you have it. The 4 roots of the given equation, which can be written in brackets as the solution set. -7 plus minus root 5 whole upon 2 and -7 plus minus root 85 whole upon 2. And that was the last type, in a sense, but not exactly. I'll explain what I meant by that in the next lesson. See you then.